For the unit 1, I choose the problem 2.3 that states that the slope of the 6.5 kilonewtons force F is specified as shown in the figure. Express F as vector in terms of the unit vectors y and j. That means that we need to find his vertical and horizontal components. Okay, first we have to make to move this vector to the origin, and we have it here, and the same data that we have here we have in this place. See that it's 12 and 5. Okay, from this we need to find the angle of this side. Okay, first the angle of this, it's equal to this angle. We can make a square here, and this angle is equal to this angle, and obviously this angle is equal to this one. Okay, so from here we can analyze this. Okay, I'm going to name this angle like A. So this angle, so this triangle is equal to this triangle. So this side have 12 and this side have 5. So from there we can work. Okay, and to understand better the problem, I want first to do the next thing. I want to take the 180 angle of all of this plus the A angle. So we're going to write it here this way. And we have this angle. And this is equal to this angle, which is A. And we're going to name this angle B, beta, which is equal to A plus 880 degrees. So to find the angle A, we need to use the tangent because we have the opposite and the corresponding cathetus. So for that, we can use the inverse tangent. We're going to write it this way. Here is arctan of, we need to find this angle. So for tan, its tangent is equal to opposite cathetus over adjacent cathetus. That means that inverse tan of opposite cathetus, which is 5, over the adjacent, which is 12. Now we make the calculation, which is this one. Arctangent of 5 over 12, and it gives this 22.619. We round it to 62. So this operation is equal to 22.62 degrees. And this is the value of A. So we write A is equal to 22.62 degrees. And now we need to find beta. and beta is equal to A plus 800 degrees and 180 degrees, I mean. So from this we have A, which is 22.62 degrees plus 180 degrees. So we find that beta is equal to 22.62 plus 180, which is equal to 202.62 degrees. Okay, from there to find the vertical and horizontal components, we need to find the magnitude of this side and from this side, which is equal to these ones. This is going to be the vertical component and the horizontal component. So for that we need to use sine and cosine. In this situation, because of this is the angle, we need to use first for the vertical component, for the horizontal component, I mean, because this use the adjacent cathetus, the cosine. So for the vertical component, for the horizontal component, I mean, we found that mhm, we find that is the force, which is 6.5 kilonewtons times y times cosine of 202.62 degrees. I'm going to make the calculation. 6.5 times, right, 6.5 times cosine 6.5 times cosine of 202.62 degrees. And that gives 5.9099 and negative. So we're going to round it and we find that the horizontal component is equal to 6 minus 6, and we wrote the I, minus 6i. For the vertical component is the same, but for this situation we're going to use the sine. It's the same with the same force, 6.5 kilonewtons times J times sine of 22.62 degrees. Here we're going to do the calculation again. Of 6.5 kilonewtons times sine of 202.62 degrees, and that gives this minus 2.5 J. Now we have the horizontal and the vertical component, and To write it in that form, in form of the components, we need to put in this way. We have the horizontal, which is minus 6y, and the vertical, which is minus 2.5 j kilonewtons. So this is the answer for this problem. It's the force, write it in a vector term, use it the vectors y and j, which is the vertical and horizontal component. And this is the answer.